In the video today, we're going to be looking at how to calculate the critical path of activity charts. The critical path is the longest path from the start vertex to the finished vertex. So we're looking for the longest duration from start to finish. You can also calculate this by looking at zero float time. We're going to be looking at examples of each, where one, we're going to calculate the longest duration from start to finish, and then we're going to look at examples of calculating float time of each activity, and any with zero lie along the critical path. The critical path represents a sequence of activities that are time critical, which means that any delay to these activities will cause a delay to the entire project. So it's important that any activities along the critical path actually maintain the duration that they're set at. Any activities on the critical path are called critical steps. With activity charts, there will always be at least one critical path, and sometimes there's more than one. Let's look at a simple example where we're looking for the longest duration from start to finish to work out the critical path. So as you can see here, there's two options. We can either go from start to A to C to finish, or we can go from start to B to C to finish. And what we're going to do is we're going to add both of the durations to calculate, and we're going to see which one's the longest. So A plus C, so we go by their durations, so 1 plus 2 is 3, and then B to C, and here are their durations, so adding them, so B, 3 plus 2 equals 5. So this is the longest duration, which means the critical path for this particular activity chart is BC. And that's because it has the longest duration. Let's go through a few more examples. So it says find the critical path of the following activity charts. So let's do A first. It's very similar to the one that we just completed, but with different durations. So the first pathway that we could take is to go from start to A to C to finish. So all we're going to do is add those two durations. So 6 plus 2 equals 8. The second pathway is to go from start to B to C and then finish. So that's 3 plus 2, which equals 5. Now the longest duration is 8, so our critical path for this activity chart in part A is AC. Let's look at B. So again, we can go from A to C to D to finish, which is our first pathway, or we could do start to B to D to finish. So there's two different options here. So A plus C plus D. So that's 3 plus 2 plus 6, which gives us 11. The second option is to do start to B to D, so that is 4 plus 6, which gives us 10. And the longest pathway is this first one, so our critical path for part B is A, C, D. Let's do one last example. So this one's a little bit more complicated. It has a few more options. The first one that we're going to do is we're going to go from start to A to E to F to finish. So we're going to do 3 plus 2 plus 7, which gives me 12. The second option is to do B to D to E to F to finish. So that's going to be 4 plus 6 plus 2 plus 7, which gives me 19. And the last one's quite simple. It's just start to C to F to finish. So that's 13 plus 7, which gives me 20. So in fact, it was our simpler pathway that has the longest duration. So the critical path for this particular activity chart is CF. Now we're going to be looking at how to calculate float time to be able to find the critical path. The float time is the amount of time that a task in a project network can be delayed without causing a delay to subsequent tasks. So if you have a float time of 0, it means that it cannot be delayed at all, as the float time is 0. So that's why any activities with a float time of 0 are along the critical path, because these cannot be delayed. If you calculate the float time of an activity and say it's 1 day, that is telling us that that activity can be delayed by 1 day without delaying the entire project. We calculate the float time by subtracting the earliest start time from the latest start time, and we use this formula here. Critical paths can be identified by the float time of the activities, whereby every activity in the critical path has a float time of 0, because it's telling us that these particular activities cannot be delayed by any amount, and therefore are critical in not delaying the entire project. Let's go through an example. It says complete the following task for the activity chart below. The first thing that we're going to do is we're going to list the earliest start time of each activity. We're then going to list the latest finish time and the latest start time. We're then going to find the float times of each activity, and therefore we're going to be able to identify the critical path. We're going to use a table very similar to the one that we used when completing the previous chapter. So the first thing we're going to do is look at the earliest start time, so part A. And we can get this straight from our activity chart. If you look at the different boxes, the first box actually indicates our earliest start time. And if you remember with earliest start time, we actually use forward scanning. So if you go through and forward scan, you'll be able to get the earliest start time for each activity. So for A, that will be 0, B is 10, C is 0 as it starts from the start vertex, D is 25, and E is 25. So part B says to list the latest finish time and the latest start time of each activity. If you remember with the latest finish time, we actually have to do backward scanning. And you can actually get this from the chart by going backwards and looking to the other side of these boxes. So let's go through and fill them out for each one. So for E, it's 35, D is 35 as they both project out from the finish point. C is 34, B is 25, and A is 10. And if you remember from our previous chapter, to find the latest start time, we're going to use this formula here, where we're going to subtract the latest finish time by the weight of each activity. So for A, the latest finish time was 10 and its weight is 10. So activity A's latest start time is 0. B, 25 minus 15 as that is its weight. So the latest start time is 10. C, 34 minus 5 gives me 29. D, 35 minus 1 is 34. And lastly, 35 minus 10 for E is 25. So that is part B done. Now we're going to do C. And what we're going to do is find the float of each of the activities. And what we're going to do is subtract the latest start time, which we just found in B, and the earliest start time, which we found in A. So you'll see here we're going to go 0 minus 0 equals 0. 10 minus 10 gives me 0. 29 minus 0 is 29. 34 minus 25 gives me 9. And lastly, 25 minus 25 equals 0. So if you remember, any of the float times calculated that are 0 are along our critical path. So activity A, B, and E are our critical path. So that is from start to A to B to E to finish. So our critical path for this particular activity chart is A, B, E. And we found that by calculating the float time of each activity. Let's look at another example. So it says consider the activity chart with the earliest start time and the latest finish time given on the right. So very similar to the last question that we did. So part A says list the early start time and the latest finish time and the latest start time in the table. So let's go ahead and get all that information from the chart. So the first thing that we're going to do is the early start time, and that we get from our activity chart. So A is 0, B is 0, C is 0, D is 3, and E is 8. The latest finish time, and we do this by backwards planning, we get that from the activity chart also. So E is 12, D is 12, C is 8, B is 12, and A is 5. Now the latest finish time is to subtract the latest start time is to subtract the latest finish time by the weight of each of those. So if we calculate those through, A is 2, B is 6, C is 0, D is 2, and D is 5, and E is 8. Now lastly, our last step is to calculate the float. So we're going to subtract the latest start time and the earliest start time to get our float. So the first one would be 2 minus 0, which will give me 2, 6 minus 0, which will give me 6, 0 minus 0 gives me 0, 5 minus 3 gives me 2, and 8 minus 8 gives me 0. So again, the float times of 0 tell me which is the critical path. So for this particular activity chart, we go from start to C to E. So our critical path for this particular activity chart is CE. Let's do one more where we look at actually calculating the earliest start time, the latest finish time, and so on. So this time they're not given to us, and we're going to have to put these through ourselves. So it says find the critical path of the following activity charts. So we're going to draw up the table first. Once you've done that, you can then fill it in easily, and also to draw in little boxes at each of the vertexes, just like we did in our previous chapter. The first thing that I'm going to do is to fill in all the boxes, and I'm going to do that using forward scanning and backward scanning. I'm going to do this really quickly. If you needed some more help or support on that, you can go back and watch the previous videos. So if we do from the start, it's going to be 0 and 0, 3, 3, 12, 16, got to add one here, which will be 8 and 8, 19 and 19, 15, 15, and 4 and 8. And using that information, I'm going to fill in my table below. So for 8, 0 and 3, 0 and 8, 3 and 16, 3 and 8, 4 and 15, 8 and 16, 8 and 15, 12 and 19, and 15 and 19. So you've got to remember, when you're going through forward scanning of earliest start time, you want to be looking at the largest amount when following the pathways, whereas doing backward scanning and trying to find the latest finish time, you're looking for the smallest duration. So now what we're going to do is we're going to find our latest start time, and we're going to calculate those. So we're going to do the latest finish time minus the weight. So for the first one, it's 3 minus 3 is 0. Next one is 8 minus 4 is 4. C is 16 minus 5 is 9. D is 8 minus 5 is 3. E is 15 minus 3 is 12. 16 minus 4 gives me 12 for F. G is 15 minus 7 is 8. H is 19 minus 3 is 16. And lastly, I is 19 minus 4, that gives me 15. So now we're able to calculate the float of each of those by subtracting the latest start time and the earliest start time. So let's do that for each of them. So for A, it's 0 minus 0, which gives me 0. B is 4 minus 0, gives me 4. C is 9 minus 3, which gives me 6. D is 3 minus 3, gives me 0. E is 12 minus 4, that gives me 8. For F, it is 12 minus 8, which gives me 4. G is 8 minus 8, which is 0. H is 16 minus 12, which gives me 4. And lastly, I, which is 15 minus 15, is 0. So any of these pathways with a float time of 0 lie along our critical path. So for our critical path here, it's A, D, G, I. So A, D, G, I. So if we look at our activity chart, that's A, D, G, I. So that tells us that for each of these activities along this critical path, they cannot be delayed at all. They need to stay in the durations that they're set, or if that happens, then it actually delays the entire project. So remember, there are two ways to find the critical path. One is to find the longest duration, and you can do those with really simple activity charts. But a lot of the times you'll be asked to do the float time and calculate that. And the best way is to set up a table like this so you've got all your values ready to go when calculating. And any activity with a float time of 0 lies along our critical path. And it's important, one, to draw them on our diagram, but to also to write it out as our path here.